So, I really hate putting true and false on there, but I like marking true and false. And the only reason that I continue to put it on is because I know that these are the kind of questions you're going to see if you're taking physics in the future. Okay, so, and I try to limit it. I certainly would not give you an entire test full of true and false. It's never going to be more than 4 or 5 marks. And some are usually pretty easy. Like the first one. Did anyone get it wrong?
Nope.
I usually try to put one on there that's pretty easy. Electric field, that's true, right? Away from positive towards negative. Okay. The modified true and false, you have to change the letters and the words in italics. So yeah, you should read the instructions. That's a good lesson. Positive test charge is placed in the space between two large equally charged parallel flat plates with opposite charges. The electric force on the positive charge would be not greatest near the negative plate. That is false. It is equal throughout the area. It's the same everywhere. Okay? Parallel lines. Force vectors on a positively charged sphere are away from the sphere. That's basically the same question as number 1, right? True. And the purpose of the Millikan experiment was not to see if an rocket could be suspended. It was to measure the charge on a single electron, or determine the elementary charge. So that one's false. Determine the charge on a single electron. The multiple choice, A, C, D. If you didn't get 6 and 7 right, you better learn whether it's multiply or divide real quick.
A, C, D?
A, C, D. C.
No, A, C, D.
C.
A, C, D, C.
Is it? Oh, I should have made it C on the back.
Yeah, we're just finding
C. That was the name before they got big.
Probably.
Yeah. ACDB.
And then we correct.
Nah, that doesn't make sense. Let's change it.
Decimals.
Yeah. So A is B. Number 9, in the Millikan experiment, it's assumed that 2 forces are equal. State these 2 forces. They are the weight force and the electric force. And you've seen that 3-by diagram. FW down, FE up. I think everyone got it.
I just didn't get that.
Okay, the drawing, for the most part, you guys did wonderful. There was the 1 or 2 people who didn't make a completed drawing, but for the most part, you did very well. I'm just going to flip right through. Okay, now the problems. Well, the problems were a bit of a problem.
Are we skipping all the drawing questions?
Yeah, you're fine on the drawing, I'm sure. If you need some help, I'll come out. Okay. In a Millikan type experiment, 2 horizontal plates are 6 centimeters apart. Has the distance ever mattered here in these questions? No. A mass of sphere 3.2 times 10 to the minus 17 kilos remains stationary or suspended when the electric field between the plates is 600, with the upper plate positive, which makes the bottom plate negative. Is the sphere positively or negatively charged? It must be negative, because there's a weight force down, there must be an electric force up, and the only way for there to be an electric force up is if they are oppositely charged, and that's how you know. The negative must be attracted to the positive for it to be suspended. So that's just a straightforward thinking, understanding kind of question. Calculate the magnitude of the charge on the sphere. There are still some people that are not using their calculator properly. They're off by a decimal point, an exponent, and that tells me you haven't done enough practice ones because you would have gotten them all wrong. Okay, length, easy. 3.2 times 10 to the minus 17 times minus 9.8 gives you minus 3.136 times 10 to the minus 16. Okay, you literally on your calculator go 3.2. You do not go times 10. Do not go times 10. Are there teachers that tell you to go times 10? There were at one point, and I had to go straighten them out.
My calculator.
It is not. Use the EXP button. That's what it's for. Use an EE button. You have one of those 2 buttons. If you don't know, Ask me. I'll show you. I went around and I spent about 20 minutes one day showing people.
You didn't even use that button.
So you say not to use it, but why? Like, why not?
Because that's what that button's for, is the EXP and the E button. Because what people, you know what they do? Is they do both. They go times 10 EXP. They try to do both. And that's why you're out. Don't do it. Okay, therefore, the electric force is 3.136 times 10 to the minus 16, but it's positive and it's up. Right? And that's equal to Q times E. Right? So I got this number here, 136 times 10 to the minus 16. I'm going to divide by 600 is giving me my Q, and you get a charge of 5.2 times 10 to the minus 19 coulombs.
What is it?
600. So that's the magnitude of charge in coulombs. And then does it have extra electrons or a lack of electrons? It has to be negative, which means it has extra. If it's negative, it must be extra. How many extra? 5.2 times 10 to the minus 19 divided by 1.6 times 10 to the minus 19 gives you about 3.2, and I'm perfectly happy with you rounding that down to 3 extra electrons. Peter, put the device away, please.
I minus the 5.22, like the 3.2.
Yeah,
minus
they're equal. They're equal. Right? Okay. So that's sort of a beginner Millikan question. An oil droplet of. This is worth 6 marks. There's a lot of steps here. You got to show your work. Step 1 is take that. Notice that it says diameter and it's in bold and it's in centimeters. When you graduate, they don't give you a diploma unless you can convert in the metric system. Did you know that? On the day of graduation, there's a metric system exam, and if you don't pass, you don't graduate.
Like,
Seriously.
from high school.
Yeah.
There's obviously
There should be, though.
No, it shouldn't.
There should be. You have to know how to convert. Were you worried? You have to be able to convert centimeters to meters, you guys. Come on.
I was thinking about Lane. I was like, well, Lane's not graduating.
Mr. Sheldon has an app on his phone that helps us convert all that stuff.
I won't even let you use it. You have to be able to convert centimeters to meters. You have to know that there's 100 centimeters in a meter. Yes. Cents. How many cents in a dollar? 100? Oh,
50 minutes.
no, we will not be using decimeters. So you're going to take 0.0001 centimeters, and you're going to divide by 100 to get meters, and then you're going to divide by 2 to get the radius.
Well, I would have got this question 5 out of 5.
It's 5 times 10 to the minus 7. If you did it halfway right, you got half a mark. You've got to be able to convert in the metric system. Volume is 4/3 pi r cubed. 4/3 pi. That radius, 5 times 10 to the minus 7. 5.24 times 10 to the minus 19. Just concentrate, you guys. Leave the lights. Ooh, flashing lights. Now, density, mass over volume, 800 Wyatt. Mass over this new volume, 5.24 times 10 to the minus 19.
I figured out that was
Okay, less, Lane. Come on. There's your mass in kilograms. Then go FW equals mg.
Yeah, I cannot remind you of the only kind of I
4.1.
was on track to being on time this morning, but then I went to that.
What's it say up there? D.
D equals M over V. Yeah, well, we did these.
No.
I think I told you what's going to be on the test, I bet you 5 times. There was no surprises, except maybe the true and false maybe. You knew exactly what was going to be on this test. And you get a cheat sheet, you guys.
He should eat that.
It went cranked right up.
Apparently I've lost the room, so. Number 19.
Yeah, man. I got 3.5.
Okay, in number 19 here, it's not suspended. Exactly the same process, except what? Except the FW and the FE are not the same. And I made it simpler. Okay, so the first step is to find the weight force.
You must keep an extra forward.
7.3. Yeah, you're probably one of those people. Are you hitting times 10 on your calculator? No, because you're always off. All your exponents were always off.
Probably because I didn't round it to like.
No, you're off by a full exponent.
I went 3.6 times 10.
Okay. Now, do you see what you're doing?
What?
Like you're going to unplug something or pull something off the table. Trying to pull that chair with your foot. I don't have a problem with you putting your foot up, but just look at the cables underneath.
Oh, sorry.
Okay? That's what I'm saying.
Oh, you were saying?
No. Cole wasn't saying anything. I got the weight force. Now go figure out the electric force. Okay, well then you need to investigate how that works in your calculator.
I got that.
What should it have been? 3? An exponent of 3.
Oh, yeah, this is 7.15 times 10 to the minus 3.
Emergency brake, we should just, no, I can like down a quarter and a quarter and 60. Is the water truck?
Okay, so you go from where the decimal is and then move it over.
Yeah. 1, 2, 3.
Almost though. The back
Okay, I know.
Okay, so now I have the two forces. They are not balanced, which means, okay,
Take another one.
I can't, you guys, okay?
That'll work.
Because there's a weight force down, and there's electric force up, and they are not balanced, that tells us, or that means that there is a net force. Okay, so let's add them together. So the FE is up 0.0018, and the weight force is down negative 0.007154, and you get a net force down of negative 0.005354.
Definitely did not get that.
Why do you keep doing it that way?
Which way?
How come they're not in
Do
the...
the times 10 way. It's easier.
Okay.
How come...
Then ask a question later.
I don't know what that. I don't even know what those are. What is the 0.0018 from?
Right here?
I didn't get it. I got an equation after that.
Did you find the electric force?
You get 1 point.
And what did you get for a number?
I get 7.2 times 10. Somehow.
Did you take 3.6 times 10 to the minus 18?
Yeah.
And then multiply by 5 times 10 to the 14? Really?
Alright.
Alright, so now that we've got our net force here, now you just have to find the acceleration. F net is equal to ma. 5.36 times 10 to the minus 3. The mass is 7.3 times 10 to the 4. Solve for A. And I get minus 7.3.
Didn't come up with two names, like, didn't come up with
I got 9.6.
Oh, so there we go.
The acceleration should be around 9.8 because if there was no electric force up, then it would be falling at minus 9.8.
Because 0.0.
That's impossible.
So you're.
Probably somewhere in the 60, 65, 70 marks. Plan to be here a solid 2 hours. There's often some students that stay the entire 3 hours.
It's going to be around 65.
65, 70? It'll be long.
I'll get this wrong question.
Be ready. Okay, we're going to solve for FE here. Take that 6.76 to the other side. Becomes positive. So 6.76 times 10 to the minus 4, then minus 5.865 times 10 to the minus 4 is our electric force, which is a number of 2.3 times 10 to the minus 9. And you got to convert that to elementary charges by doing what, Lane?
Fine. You wrote it down on paper because I didn't do that.
Times 10 to the 10.
Why do you divide it?
Because you got, this is in coulombs. To convert it to elementary charges, you have to divide by 1.6 times 10 to the minus 19.
You ever times it?
When you're going from Elches to coulombs,